Hello students, welcome to the video on basic concepts of OOP. In this video, we are going to learn the various concepts of object-oriented programming. Let us see one by one. First is objects, then classes, data encapsulation, data abstraction, inheritance, polymorphism, message passing, and dynamic binding. So these are the 8 basic concepts of object-oriented programming. Let us see each concept in detail one by one. First, let us see objects. So objects are the basic runtime entities in OOP. So whenever we are writing the object-oriented program, in that the object is the basic entity. The object may represent the entities such as person, a place, a bank account, or a table of data, or a book, or a student, or an item in a store. The objects also represent user-defined data such as vectors, time, lists, etc. The programming problems which are going to solve, that are analyzed in terms of objects, and the objects establish the communication between them. The objects are created in the memory and they occupy certain memory space and thus also have an address associated with it. Each object contains 2 parts. One is data and second is code to perform operations on that data. So that code is in terms of various functions. So these functions operate on data to perform certain operations. Now the second concept of OOP is class or classes. What is class? The class is defined as an abstract data type characterized by a set of properties common to its object. So the class is having 2 parts, attributes and functions. These are called as the properties of class, and these properties are common to all objects of that class. The class is a user-defined data type for object. So in OOP, the built-in data types such as int, float, double, char are also supported. Apart from that, the class is another data type which is defined by the user itself. Hence the class is user-defined data type, and this user-defined data type is used to declare the objects or to create the objects. The objects are thus the variables of the type class. Just like if we declare int x, so you can say x is the variable of the type integer. Similar to that, the objects are the variables of the type class. You can say now the class is a group of objects of similar type. So there may be collection of objects of same class type. For example, mango, apple, pineapple, orange, these are the objects of the class fruit. So fruit is a class, and mango, apple, pineapple, orange, etc. these you can say the objects of the type fruit. In a OP program, the class you have to define first. Once the class is defined, then you can create the objects of the type class. So in this way, in a program you have to define the class followed by the creation of objects. The third concept of OP is data encapsulation. The fundamental idea behind the OP approach is to combine the data and functions into a single unit. So here the data and functions. What are the purpose of functions? The functions are operating on the data. So the data and functions are put into a single unit. That unit, how to create that unit? That is nothing but your object. So the wrapping up of data and functions into a single unit is called as or is known as encapsulation. So the process of wrapping up data and function together in a single unit is known as encapsulation. So here the main word is capsule. The capsule is used to protect something inside in it. So here, what is inside the capsule? There is data and functions. So these are the two entities, data and functions inside the capsule, and that process of wrapping up this into a single unit, that is known as encapsulation. Due to this encapsulation, the data is protected inside the object, and thus the data is not accessible to the outside world. So here the data is totally protected inside the object. The encapsulation means actually the protection of what? The protection of data. Protection of data from what? From the access by outside functions in a program. So in a program there may be other functions apart from the functions within the one object. So this data is protected from outside functions. So that particular process or the mechanism is called as data hiding or also information hiding. So the encapsulation of data from direct access by outside functions in a program is called as data hiding or information hiding. So now we can say that the data encapsulation is used for data hiding or information hiding. The data is hidden within the object and it is protected from the external world, that is outside the object. That data is not accessible to the outside function. Outside the object means there are other functions in other objects, they cannot access the data within another object, and like this the data is being protected, the data is being hidden, information is being hidden. So this is the concept of data encapsulation. The next concept is data abstraction. What is data abstraction? The abstraction refers to the act of representing essential features without details. So we can explain anything in terms of its attributes or properties without its more details. That is nothing but the abstraction. The abstraction also defined as hiding an implementation details from user. So whenever you are defining the abstraction or abstract data, so the actual implementation is not given in detail. So in this way it is hidden from the user. What operations will be performed, what type of implementation will be done, that will be hidden from the user. Here in OP, the classes use the concept of data abstraction. So when you define the class, in that there is a data and functions operating on it. So at the time of defining a class, there is no implementation at all. The details are not there, and hence the concept of data abstraction is implemented in terms of class. And thus classes use the concept of data abstraction, and hence they are also known as abstract data types, that is ADT. So classes are the abstract data types because they follows the data abstraction. The classes are defined as a list of abstract attributes such as size, weight, cost. These are the data and the functions to operate on these attributes. So here size, weight and cost. So for that the functions may be the find the area of that particular shape, or find the total cost of n number of atoms. So like this, functions can be defined to find these quantities, and thus these functions will operate on these attributes. So size, weight, cost are the attributes, and the operations that will be performed on size, weight and cost will be the functions. So like this, in the whenever we are defining the classes, it is defined as a list of abstract attributes. Abstract means at that time of definition of these attributes do not represent any details or any value. They are at abstract level. So this is the concept about data abstraction. The next concept is inheritance. What is inheritance? Inheritance is the process by which objects of one class acquire the properties of objects of another class. So like this, there is a relationship between two classes. There will be one class, and with the help of that class, the another class will be related to it, related with it, and in that the object of one class acquire the properties, whatever the properties of the object of another class, that will be automatically acquired within the object of second class. Let us see in detail. Now in OP, the concept of inheritance provides the idea of reusability. So this inheritance concept provides the feature or the idea of or a characteristic of reusability. Reusability means what? The reusability allows to add additional features to an existing class without modifying it. So one class is defined. In that class there is a data and some functions operating on that data. Now if in future I want to add some additional attributes or additional functions to that particular class without disturbing that class, I can define another class with the help of the previous or existing class with additional features. So like this, the existing class will be reused to add additional features. That is nothing but the reusability. Now due to this, it is possible by defining a new class from the existing class. Just I told you that there is one existing class which is already having certain data and functions, and with the help of that existing class I can define a new class. In this new class there will be the features or the all attributes of existing class will be automatically inherited into new class, plus some additional features can be added. So that is happening due to inheritance. In this way the new class will have the combined features of both the classes, that is the features of existing class plus the features of new class. So this is the effect of inheritance. So finally, the mechanism of deriving a new class from existing class is called as inheritance. So deriving means what? Creating or defining a new class from existing class, so that the features of existing class will be inherited into the new class, and the new class will have the combined features of existing class plus new class. So this is the concept of inheritance. Let us see the example. Here bird is one class which is having certain features like feathers and lay eggs. Means every bird is having feathers and every bird lays eggs. So these are the common attributes or the features of a bird. Now from this bird class I can create or define two other new classes. One is flying bird and another is non-flying bird. Now flying bird will have the attributes that these birds can fly, and non-flying birds are the birds which cannot fly. So here there is a difference between these two classes, is that the feature of flying bird class is the birds that can fly, and the feature of non-flying class is the birds that can fly. So both are the birds only. So like this, the features feathers and legs are already derived into flying bird as well as non-flying birds. Like this, flying bird is having the feature feathers, lay eggs plus cannot fly, that is no wings. Here wings, that is feathers, can lay eggs and wings. Here in non-flying bird class also the feathers and lay eggs, these attributes are inherited from the bird class, plus the non-flying bird is having its own attributes, that is they are having no wings so that they cannot fly. So like this, here the bird class is called as a base class, and these flying birds and non-flying birds, these are called as derived class. Now flying birds will be the two, that is the two, these are the objects. Robin is a flying bird, swallow is a flying bird, penguin is a non-flying bird, kiwi is a non-flying bird. So all these are the four objects. So robin and swallow are the objects of flying bird class, while penguin and kiwi are the objects of non-flying birds. And these flying birds and non-flying birds are the derived classes of bird base class. So like this, there is inheritance. The properties or the attributes of bird class are inherited into flying bird and non-flying bird classes. So like this, the object robin and swallow will have the combined properties or the attributes of bird class plus flying birds, while the penguin and kiwi, these two objects will have the combined features or the properties of bird and non-flying bird. So like this, the inheritance can be implemented. The next concept is polymorphism. What is polymorphism? Polymorphism means the ability to take more than one form. So there is one thing, and that can be take more than one form. So an operation may exhibit different behavior in different instances, and this behavior depends upon the types of data used in the operation. So there will be certain operation, that is, the operation will be performed by the function, and the function may perform different operation depending on what type of data is used at that time or at that particular instance. So like this, the same function can perform different operation depending on the type of data used in that operation at that particular instance. So in this way, the function will be the polymorphic function, that is, the function or that operation is having the ability to take more than form. The polymorphism can be implemented using function overloading, function overriding, and operator overloading. So these are the three concepts or the operations that we will study in detail afterwards in further units: the function overloading, function overriding, and operator overloading. So using this, the polymorphism can be implemented. In short, function overloading means one function, same function name, will perform the different types of operation. For example, area is a function, and this area function, if I provide the radius as argument to this function, it will find the area of circle. If I provide length and breadth as data or the argument to the function, it will find the area of rectangle. If I provide three sides of triangle as arguments to the function, it will find the area of triangle. So like this, the function is one, that is area, but it will behave differently at different instance depending on what type of argument you are providing to that function, that is function overloading, and that is the example of polymorphism. Similarly, operator overloading, one operator can perform different operations. For example, the addition, if I provide two numbers, so it will perform the sum of two numbers, and if I provide two strings to add, then it will perform the string concatenation. So like this addition plus operator can perform the addition of two numbers as well as concatenation of two strings. So here it is a polymorphic nature, means there are two behaviors. One behavior is finding the sum of two numbers, another behavior is to concatenate two strings. The polymorphism allows the objects with different internal structures to share the same external interface. So due to this polymorphism, the objects can share the same external interface, means to the external world it appears as a single, but internally it has different internal structures. So that is happening due to the polymorphism. Let us see the example again. Here there is a class shape having the function draw. So draw function is used to draw a particular shape. Now here there are three objects created of the type class shape: circle, quadrilateral, triangle. So these are the three objects of class shape. The circle, in the circle there is a draw function. So this draw function will draw a circle, while for the object quadrilateral it will draw a quadrilateral shape, while for a triangle object it will draw a triangle. So like this, the draw function is behaving differently at different instances. At one instance it draws a circle, at another instance it draws a quadrilateral, while at third instance it draws a triangle. So this is nothing but, so the draw function is having the polymorphic nature. So here the polymorphism is implemented in terms of a draw function, and it is also the example of function overloading. The same draw function is performing different operation depending on the type of object and the data provided to it. The next concept of OP is message passing. Now, whenever we are creating the objects in a program, these objects can communicate with each other by sending and receiving information, and this information or data which is sent to each other by the object is called as messages. So with the help of one message, one object can request to another object for getting certain data from it. So this is message passing. A message for an object is a request for execution of function. So what is actually a message? At lower level, it is nothing but a function. The object calls a function to execute, and the function will return certain value or will return data or result. So like this, a message for an object is nothing but a request for execution of a function. How the object executes the function, we will see. The message passing involves specifying the name of object, the name of function, and information to be sent. So whenever there is a message passing happening, there are three parts in a sequence. We require object, that is which object want to communicate, then what is the name of function, that is with the help of which function the object want to communicate, and what type of information will be sent along with the function to perform the operation. So these are the three things required for the message passing. This is the syntax, how the object calls a function. You have to write the object name, function into bracket arguments. For example, customer dot display into bracket 1145. So here customer is an object, display is a message, and 1145 is a data. So as we have mentioned in this point, that is message passing involves specifying the name of object, the name of function, and the information to be sent. So this is name of object customer, name of function is display, and the information sent is 1145. So here the customer object is requesting to display the account details of 1145 account number. So like this, the balance of this account, or then what is the name of the customer, what is the balance of that account, so that information will be displayed. So in this way the message passing is done with the help of object, function, and the information, and the object will communicate with another object to get this type of information. So this is the concept of message passing. The last concept of OP is dynamic binding. What is dynamic binding? The dynamic binding means that the code associated with a given function call is not known until runtime. Now whenever the function is executing, every object is having the set of functions and data, another object is having another set of function and data. Whenever the object calls a function to execute, and whenever the function is executing, the function, what is the code, which code to be executed, that is not known in advance until the runtime. So the decision will be taken at runtime which code to execute. That is nothing but the dynamic binding. The code to be executed is selected at runtime. So just I told you that if that particular code, that is whether to draw a circle, whether to draw a rectangle, whether to draw a triangle, that is not known in advance. When at the runtime, what type of data is provided, according to that, which function to execute or which code of that function to execute, that will be selected at runtime, means while running the program. The same function executes different code dynamically depending on data entered at runtime. Just I told you, whenever the function executes at runtime, then when you run the program, what type of data is entered as an input, depending on that, the code to execute will be decided. So that is called as the dynamic selection of code execution. So like this, the same function executes different code dynamically depending on the data entered at runtime. For example, there is an area function, and the area function, if I enter radius, the area function executes the code of calculating area of circle. If the data entered is length and breadth, at runtime, then the area function executes the code to find area of rectangle. If the data entered is 3 sides, then at runtime, then the same function will execute the code of finding area of triangle. So this is called as the dynamic nature. So in this way, the same function executes different code dynamically depending on the data entered at runtime. It is associated with polymorphism and inheritance. So data binding, this concept is you can say the part of polymorphism and inheritance. A function call associated with a polymorphic reference depends on the dynamic type of that reference. So just I explained this particular statement, the same thing is explained here again. The function call associated with polymorphic reference. Polymorphic means what? Dynamic reference. Which function, which code to execute? It is depending on dynamic type of that reference, means what type of data is entered. So like this, the polymorphism is also achieved here due in this dynamic binding. So this is the concept of dynamic binding. So like this, we have studied, learned objects, classes, data encapsulation, data abstraction, inheritance, polymorphism, message passing, and dynamic binding. So these are the 8 basic concepts of object-oriented programming. Thank you students for watching this video on basic concepts of object-oriented programming.